Okay, great. So for this session, I'm going to talk to you about accessing and exploring data through our website. And for today's example, for this session, we're going to be using data from the Amazonia Isomer Brazil cohort. So just to give you guys a little bit of information and background, this is a data set that was collected over a 4-year period in the Brazilian Amazon from 2010 to 2014. This was done by one of the isomers, so this is International Centers of Excellence for Malaria Research, and there's a number of isomers spread around the world, and the goal of all these different isomer programs is to really try and understand malaria epidemiology and biology in different contexts. So this one was a study done by the Amazonia isomer, done in the Brazilian Amazon over that 4-year period. And so for the questions we're going to be asking of this data set, we're going to look at things like, is there any potential association between variables like sex and people's activities, like who's going into the forest, who's going to the river, and also is there any association between sex and who's getting what species of Plasmodium? Because for malaria, you can be infected by Plasmodium falciparum or Plasmodium vivax, and both are there's other species as well, but those two are the main species prevalent in this part of the world. So those are the questions that we're going to be looking at here. And just as a reminder, if you clicked right here, you would go to the study page so you could find out more information about this study. And if you click, you can read the study card. If you want to download the data without even looking at it, you can click here. But this study in particular has data access restrictions, so you actually have to submit a request and be approved first. But anyone can go in and explore the data. And so you'll see here at the bottom of the card, this particular one has 3 different icons. There's a participant icon, an observation icon, the stethoscope, and a household. And these initiate different types of searches. What this means is that whether you click on a participant or observation search, you're going to see the same variables, you're going to see the same data tabulations. The difference is going to be, the main difference is going to be at the end if you try and download the data from this search. If you do a participant level search, you're going to get 1 row of data per participant. If you do an observation level search, you're going to get 1 row of data per observation. And this was a longitudinal cohort study, so you have multiple observations per participant. And if you do a household search, you're going to get 1 row of data per household. And in this study, they had multiple participants enrolled that would come from 1 household. So those are the main differences. There's some other slight nuances, and I'll mention those as we go through. But the usual search that people do for most data sets is a participant one. So that's what we're going to do here for this isomer. And this takes you straight into the data. And so just to get you oriented first, at the top, you see the name of the study. You can click here to go to the study page again. You always want to have access to the methodology and other information. There's a brief summary of the study here. And then this is what we call our search wizard. And this is categorizing variables into these different steps. So under household, you're going to find variables that are related to the house. So you can click to expand all or collapse to quickly see them. But basically, as you might expect, you see things like what types of floors and walls and what type of material were used for the floors, walls, and roofs of these homes in the Brazilian Amazon. You can see what types of assets people had, socioeconomic related variables, like did they have chainsaws, motorcycles, radios, things like that. Under participant, you normally find variables that theoretically don't change over time. So things like sex, birth date, information like that. If there's any genotypic information on the participant, you'll find that here, like in this case, they have blood groups for ABO and RH blood groups and Duffy blood groups. And then observation is where you normally find the bulk of the variables. So these are going to be things like that change over time. So even if it's a cross-sectional study where the data, every participant was only asked, data was collected from every participant only 1 time, because in theory their weight could change over time, you're still going to find those variables under observation. So it'll be things like anthropometry, weight, height, temperature. You're going to find things like signs and symptoms, clinical history. You're going to find often if they collected travel history, you'll find that. And this, obviously, it will really just depend on what variables the study was collecting. And then also sample data, so lab tests, those you'll often find under this step. So this is nice if you want to explore the data, you can just click through and look at all the different variables. But if you come into a study and you have specific questions in mind, you can actually search directly for things that might, variables you might be interested in. So if I know that I want to look at plasmodium in this study, I can start typing in plasmodium in this search box. And then I can see that there's all these variables with plasmodium in the label that I might want to look at. If I know that I want to look at for variables that have a value of, say, female, I can type in female, and then I see there's only one variable, and that's sex. And when I clicked on that, it took me right to that variable, and now I can see a data table for that variable. So this search box, it searches the names of the variables, it searches the values. If there's a definition for the variable, it searches that as well. And finally, if you do happen to know what the variable was originally called in the data set itself, you can look for that as well, and it searches for that. So if I typed in, in this case, you can see the original name of the variable was sexo. So if I type in that, I can still find this variable. Okay, so that's how to start searching for variables. But in our case, as I mentioned earlier, what we want to see here is if there's any kinds of associations we can start to pull out between sex and activity. So here we're looking at a table of categorical data. So what we get is on the very left-hand side, you see the name of the variable and all potential values listed below it. In this column here, you get the counts. So at the top, you get the total count. So you can see that 640 participants answered this question. And of those, 270 were female and 370 were male. So 58% of the participants in this study were male. And this is represented graphically here to the right. So you can see here in the sideways bar chart that there's slightly more males than females in this particular study. So if I want to subset the data, I can actually just click this checkbox, and now I've gone from 640 participants. So these numbers up here tell you at any time how many participants you have. If I were doing an observation level search, I wouldn't see 640, I would see a larger number, more like 3,000, because there's a total of over 3,000 observations. But we're doing a participant level search, so the counts here are at the participant level. So we go from 640 participants down to 370 after I check this box. So going forward in this remaining participants column, we're going to see the counts for just males. That's how that works. So I wanted to look at the association between sex and activity. So I'm going to go over here, and under activity, there's a few different variables we might be interested in, like who's clearing new plots of land in the forest, who's going to the forest at night, who's sleeping by the river. For all of those, we might expect that there to be more males doing those tasks than females doing those tasks. So if I come here to clear new land, what I can see is here's the total counts. First of all, I want to point out that this variable does have a definition, and this one just points out that this was, even though it's under observation, it was only assessed at the first observation for each participant. So people didn't answer this question multiple times. So at maximum, you'll see 640 answers. We can see that 557 people answered this out of 640, and 366 said that they didn't clear new plots of land, and 191 said that they did. And again, you can see, if you look at the total bars, that's represented graphically here. But if we want to look just at males, that's what this count is here, the remaining observations. So this is after any subsetting or filtering you've done. These are the counts for that specific data set. So in this case, males only. So here we see 173 males said no, 146 said yes. So out of 191 people total who said they clear new plots of land, 146 of them are male, and that's 76%. So most of the people who are clearing new plots of land are male. And in this graph, you see that now instead of it being entirely pink, it's partially pink and partially gray. And the pink part is anyone who's matches what you've filtered on. So in this case, it's the males. And the gray is everyone else. So in this case, that's females. So that's how you can get a quick idea that it looks like, more males than females are clearing plots of land. If we look at in the forest at night, you see something pretty similar, that for people who say that they're in the forest all the time, there's only a total of 4 people who say that they're in the forest, and 3 of those people are males. For people who are sometimes in the forest, there's only 64 people, but 60 of those are males. So it really looks like people going to the forest at night are more likely to be male than female. You could look at the reason that they're going if that's something you are interested in. We could also look at who's sleeping by the river. And again, most people are not sleeping by the river, but of the 53 people who are, 48 of them, or 91% of them, are males. So this is a pretty nice way to look at, you know, to start exploring potential associations between variables. So another thing we might be interested in with this data set is, okay, so we're seeing that males are the ones who are more likely to be doing these outdoor activities. Is there also any difference in who's getting infected with Plasmodium? So if we look now instead for Plasmodium variables, we can see there's a number of variables here, but for today's demonstration, I'm going to focus on this one, which is a combination of data from microscopy and qPCR, looking at who has which Plasmodium species was identified. And so what we can see here is, again, this column here is the totals, the overall totals, and this column here is the totals for males, so after the filters have been applied. So you can see that overall, at most observations, people were negative for any kind of Plasmodium infection. So out of 1,800, just over 1,800, close to 1,900 observations, 90% of them were negative for any Plasmodium. There were 1% of observations, or 10 observations of mixed infection, 40 observations of P. falciparum infection, and 142 of vivax total. But if we look at, for males specifically, we see a slightly different picture than we might expect based on the fact that 58% of the population were males. We see that 30 out of the 40 P. falciparum infections occurred in males. So 75% of P. falciparum infections were in males, whereas 76 out of 142, or 54% of P. vivax infections were in males. So it seems like for some reason, males are slightly more likely, if someone has a P. falciparum infection, they're more likely to be male than female. And that may or may not be related to the fact that it's males who are more likely to be going outside into the forest and sleeping by the river. And maybe that has something to do with which mosquitoes are biting them and which parasites they're hosting. So that's something that might be worth digging into further in the future. And it's a great way to start getting a sense of potential associations in the data. So with all of this, I was showing you categorical variables. I also want to show you what it looks like if you're looking at numeric data. So, weight is one example. You see there's a histogram, but let's look at date for this example. So here you see this histogram, and I just want to point out that if you're looking at data on a histogram, there's actually a lot of tools so that you can change how the graph appears. So you can, if you only wanted to look at data in 2010, for instance, you can update the settings here. And now we've zoomed in on data from 2010, so it's easier to see. And again, pink is data that matches your filters. So it's males in this case, and gray is all the remaining counts, or females in this case. And then I can also change the bin width. So right now, every day is a bar. And if I wanted to look at it by week, I can change that to 7, and I get thicker bars. It's a little bit easier to see. And I can mouse over to get the total number of counts for each bar. So that's how to interact with histograms. So another question I might have from this data set is, do we see changes over time in the numbers of infections that are occurring, or the types of infections that are occurring? So for this, I'm going to take away the previous filter. And so what I did is, you'll see here, there's these green filter icons, and these just show you all filters that are currently applied. If I click this link, it'll take me straight back to the variable, and I can edit my selections there. But in this case, I just want to remove that filter. So I click the X, and now my counts have gone back up to 640. And what I want to do now is specifically select, I'm going to go back to the default. I want to compare the first few rounds of this study, 3 rounds of surveys were done within the first year. And I want to compare that to the last 3 rounds of surveys. So to select data here, I can click and drag my mouse to select. And the other option is, if I want to be more precise, I can use these boxes to input specific dates. So here I've selected this, and now let's go back to that Plasmodium species by microscopy. And what we can see is that in what I selected, we got about 570 observations. And we see that 75% of them are still negative, and that 7% are of those observations people had P. falciparum, and in 16% people had P. vivax, and in 2% they had mixed infections. So this is, if you look at the total numbers, it looks like 38 out of 40 infections occurred right at the beginning in the first year of this study for P. falciparum. And 65% of all P. vivax infections occurred within that first year of the study. So if you go back and reset this and now look at the last 3 rounds, we're going to see that very few infections occurred here. Only 6 P. vivax infections occurred within the last year and a half of the study, even though it's roughly the same number of observations, over 500. So again, the system really, the idea here is that it's a great way to start exploring potential associations between variables, and overall, it's a great way to start exploring what data does the study have, what variables are there, what do the data distributions look like for a variable in particular, what does the study structure look like? These are all pieces of information you can get just by clicking around within any study before you decide whether to take it further and visualize the data more or download it. And so we're going to go into those in a bit more detail next, but like Danica pointed out earlier, if you click that button at the end, it takes you to the results page. And here you have the option to add more columns to look at data on this table, to request downloads from here, and this will download the filtered data only, or to take it into these analysis apps for further visualization. And so these are all things that we'll cover in more depth over the next few sessions. And Sam, I'll turn it back over to you at this point.
Thank you, Shana. Now we